Hello all, in today's class we are going to learn one more important topic which is log-based protocols. Firstly, what is log-based protocols and why do we need those protocols? We know that when multiple transactions execute concurrently, it leads to several kind of conflicts. So there are several mechanisms which are employed by concurrency control management component of a transaction in order to ensure that the data remains consistent in the database. So whenever a transaction is to be executed, log-based protocol will employ several logs for a transaction while it is under the execution. Now we will see when logs are acquired by several transactions during its execution, in what way those logs helps the database system. The first one we have is consistency. Without logs, multiple transactions could modify the same data item simultaneously, resulting in an inconsistent state. So as we know that concurrency mechanism is allowed in database management system. It may lead to performance optimization and increased throughput as well. But then when multiple transactions are executed simultaneously, it also leads to several kinds of conflicts, which we have learned in the previous section. So in order to avoid such kind of conflicts, there are several mechanisms that are employed by the transaction management. So here, without logs, as we are talking about the log-based protocol, whenever a transaction is to be executed, it has to acquire logs. So here, without logs, what happens? Multiple transaction can modify the same data item at the same time. Then it leads to an inconsistent state. And coming to isolation, logs ensure that the operation of one transaction are isolated from other transaction. Isolation is one of the important property of transactions, right? So what is it? It says that when one execution happens, the other transaction should not interleave the execution of the other transaction. So in such a way, the transaction has to execute and provide consistent results. But with the log-based protocol, it can ensure that the operations of one transaction are separated from the other transactions, and they are invisible to other transactions until the transaction is committed. So when a lock is acquired by the transaction in execution, and when other transaction is trying to access the same data item at the same time, it is not allowed until and unless the transaction performs a commit operation. Coming to concurrency. Concurrency means what? Ensuring multiple transactions execute at the same time, so that it helps in resource utilization and increase in throughput. Not only this, we also have the overall performance of the system. So that is why logs are essential in the database system. Avoiding conflicts. Logs help in avoiding data conflicts that might arise due to simultaneous read and write operations by different transactions on the same data item. Avoiding conflicts means if logs are not used, then what happens? As discussed before, multiple transactions will try to modify the same data item simultaneously. So when transactions acquire logs in performing any sort of write operations on the data item, it will not allow the other transaction to be interleaved or to interrupt the execution of one transaction while it is under the process. Preventing dirty reads. With the help of logs, a transaction is prevented from reading data that has not yet committed by another transaction. We know what is a dirty read. Dirty read is what? Transaction is going to perform a read operation on the data item which is written by the another transaction before commit. It is known as a dirty read, right? But where in case of this log-based protocol, as the transaction acquire logs before performing a read or write operation, there helps in preventing the dirty reads. Now let us see the types of log-based protocols. The first one which we have is simple log-based protocol. The simple log-based protocol is a mechanism in which there is an exclusive use of logs on the data item for current transaction. It tells you that this particular mechanism is used in order to perform the execution of the transaction on some data item by making use of the logs. Here we have different types of logs. First one is shared log and the second we have is exclusive log. What is shared log and what are exclusive logs? Let us see. Shared log is a log that is obtained by the transaction to perform only read operation on the data item. So as we know, when multiple transaction performs read operation on the same data item at the same time, it does not affect the database system because those transactions are allowed to view the data. Clear? So here, acquiring the shared log by multiple transactions at the same time is possible. Whereas exclusive log says that when the transaction wants to perform a read as well as write operation on some data item, it has to acquire the exclusive log. Exclusive lock is given only to one transaction. After it performs the read and write operations, it is going to release the exclusive lock for the other transaction who is waiting to perform a write operation on the same data item. Let us see the example and have a better understanding of shared and exclusive lock. Here we have two transactions, T1 and T2, and T1 is acquiring a log called shared log on which data item? On A, which means this wants to perform a read operation on data item A. So before it does the read operation, it is necessary for the transaction T1 to acquire the shared log. S of A indicates what? It is a shared log on the data item A. And once the read operation is completed by T1, it is going to unlock. So here we have, it is going to release the lock which it has acquired to perform the read operation on A. And coming to T2 transaction, here this wants to perform the write operation on the data item A. So when exclusive lock is acquired by T2 transaction, it performs both the operations, that is read of A is done and write of A is also done. Once the updations are made by T2 transaction, it is going to release the acquired lock. With the help of the log-based protocol, we are not allowing the other transaction to interfere the execution of one particular transaction while acquiring the locks. Two-phase locking protocol, and this is also known as 2PL protocol, which is a method of concurrency control in database management system. It is going to ensure the serializability. Here, this two-phase locking protocol is mainly helpful in eliminating concurrency problems. And this locking protocol is going to divide the execution phase of the transaction in three different parts. The first part is that when the transaction begins to execute, it requires the permission for the lock it needs. As we have discussed about the shared lock and the exclusive lock, before it starts the execution, it needs to take the permission in acquiring the locks in order to perform any sort of operation on the data item. The second phase tells that the transaction is going to obtain all the locks whichever it requires before the execution. Then it is going to release the first lock and then the third phase will get started. So what is the third phase we have? The transaction cannot demand any new lock. Instead, it only releases the acquired locks. Let us see the example. Here we have two transactions, T1 and T2. So here you can see A shared lock is obtained on A by T1. Before it releases the shared lock, T2 transaction is also given with the shared lock to view the data on the same data item. So thereby, there is no problem in affecting the database. And coming to the next point, exclusive lock is acquired by T1 transaction to make any sort of changes on B. And here you can see exclusive lock is obtained by T2 transaction on some other data item C. The exclusive lock for T1 is given to make changes on the data item B, whereas though it releases or it does not release the exclusive lock, that doesn't matter for T2 transaction because it is performing the modifications on some other data item. Thereby, it is allowed to acquire the exclusive lock. Now, this two-phase locking protocol allows each transaction to make a lock or unlock request in two different phases. One is growing phase and the other one is shrinking phase. What is growing phase? Here we have the transaction may obtain any number of locks but cannot release it, which means when it wants to perform an operation on some data item, it is going to obtain all the locks whichever it requires, but it is not allowed to release any locks. The transaction is going to acquire all the locks in the growing phase. So how long it can acquire all the locks? Until it reaches a point called lock point. And coming to shrinking phase, the transaction may release but cannot obtain new locks. This transaction, which it has acquired the locks, after it reaches to the lock point, it does all the operations on the data item and it has to release the locks which it has obtained. But when it is going to release the locks, it is not allowed to obtain any more new locks. That is known as shrinking phase. Next, coming to strict two-phase locking, transactions are not allowed to release any locks until after they commit or abort. What do you mean by this? As discussed before, until a transaction completes its operations, whether it might be a read operation or it can be a write operation, once its execution is completed, it has to make a commit. Commit indicates what? It indicates the successful execution of the transaction. So once a transaction is successfully executed, it is now allowed to release the locks. Thereby it ensures serializability and it is going to avoid the problems of cascading rollbacks. So which is a very time consuming process as well as it is difficult to recover the schedule. A transaction can release a lock after using it, but it cannot commit until all locks have been acquired. This means once a transaction has completed one particular operation on some data item, it is going to release the lock for the requested transaction. And then it is not going to perform a commit operation until and unless the requested transaction has given the lock back to the particular transaction. Rigorous 2PL is also a deadlock free and ensures serializability. Why is it said deadlock free? Because once the operations is completed, it is going to release the locks for the other transaction. It is not acquiring all the locks though it has completed the operation. So when other transaction is under the queue and requesting for the lock to be released, that particular transaction, after completing the operations, it is going to give the lock for some other transaction. Thereby what happens? You can simply say that it is deadlock free. Next we have is conservative or static two-phase locking. A transaction must request all locks it will ever need before it begins execution. So this may lead to a deadlock situation. It is because it is going to acquire all the locks before it starts its execution. So thereby what happens? Some other transactions has to stop for a long time The logs acquired by the transaction is not going to release until its completion. Hope you have understood today's lecture. Thank you.